Hi, welcome to Unit 4, Lesson 4. We're going to continue talking about exponential growth and decay, but this time we're going to have fractions in our inputs. So same equation that we've been talking about, that y equals a times b to the x. We're going to look at an example with a population of Nigeria in 1990. So here's our basic equation we've been working with, and this question is asking us to express the population in terms of f of d, in millions of people of decades since 1990. So we write f of d, that's f of decades, which is going to be our time unit, equals our a value, which is the initial population. It's going to be 95.3, because remember we're talking in terms of millions. Now for our b value, which is rate of change, we know this is an exponential growth equation because the population is increasing. So we're going to have 1.284, 28.4 being the percentage of growth every decade. Now remember, with exponential growth, we add that 1 in front of the percentage because we want to take into account the initial population, right? So that 1 will multiply this number by 95.3 million and then also by that percentage increase. And then we just raise that to the power of d, which stands for number of decades. The second question is asking us to write the population of Nigeria in 1996, or an equation for that. So we do f of d equals 95.3 million times our rate of change, 1.284 to the power of 6 over 10, right? And let me fix that. 6 over 10 because that is 6 years out of that full decade, which is 10 years. This can also be written as 6 over 10, that fraction equals 3 over 5 simplified, or you can write it in terms of a decimal, which is 0.6. Now for this next example, we're talking about how in healthy adults, caffeine has an average half-life of about 6 hours, so half of the caffeine leaves a person's body over 6 hours. So a healthy man consumes a cup of coffee that has 100 milligrams of caffeine at noon. The first question asks, each of the following expressions describes the amount of caffeine in the man's body some number of hours after consumption, and how many hours after consumption. So in order to figure this out, first we're going to write out our base equation, right? Y equals a times b to the x, and then we're going to plug in the values we know. So y equals our initial value of 100 milligrams times the rate of change, which I'm going to write as 1/2 here because it's the same as writing the rate of change of 0.5, right? And we don't have a 1 in front of it in this example because this is exponential decay. So it's just 0.5 or 1/2 raised to the power of t, which is time. Now going back to the question, it's asking how many hours after consumption is each of these equations referring to. So this first one has a 1 as the exponent. So our time value is 1, which is equal to 6 hours, right? And the second one, it's a 3, which is 6 times 3, 18 hours. The third one is 1/6. So 1/6 of 6 hours is 1 hour. And this last one is just our base equation, right? So that's any value of t. So any multiple of 6 hours. Let's write out, it's our basic equation. Now this next question is asking us to write a function g after the amount of hours the caffeine has been in the bloodstream. So in this case, we're going to write g as a function of h for hours, all right, and then same initial amount, 100 milligrams of caffeine. And in this case, we're going to pull from that last question where we determined that 1/2 to the power of 1/6 represented the rate of change 1 hour after the man drinks the cup of coffee. So we're going to write that in here, 1/2 to the power of 1/6, and then we're going to raise that all to the power of h, representing hours. So to simplify this, just plug 1/2 to the power of 1/6 into your calculator and replace that value there. You'll get 0.89 to the power of h. Now I want to point out that you could use this equation to figure out the half-life as well, that over that 6-hour period, by just plugging in 6 for that h value. And the second question is asking us to explain why g of 6 is equal to f of 1, right? Which is because in these two different equations, so we'll put g of 6 equals 100 times 0.89 to the power of 6 f of 1 equals 100 times 1/2 to the power of 1. These are both talking about 6-hour periods. All right, thank you guys for watching. Go ahead and get to your independent practice problems and let me know if you have any questions.